Yeah, the Christmas songs are in our head now. Well, it's Wednesday. That means it's time for a science lesson here on the morning show.
Today we had to take the experiment out of the studio and into the lab. Matt Sellen joins us live from his lab to show us why. We're talking high voltage electricity, Matt?
Yes, we are. We're going to talk about how you make a high voltage and then why you want to use a high voltage to transmit electricity from one place like the power station to your house. And that's going to be in the second part. And we have a huge power transmission demo set up here. But before that, I want to describe how you get a high voltage from just a regular sort of AC voltage that you might have in your house. But first I want to say to my wife, who I know is probably still sleeping on the couch, wake up, Judy! Okay, okay. So anyways, we talked in the last few weeks about how you can generate a magnetic field by putting, if you have a bunch of loops of wire and you put a magnet through it. Or we also talked about the fact that if you have a bunch of loops of wire, you put an electric current through that wire, you get a magnetic field, like you can pick up paper clips with a battery or something. And that's the way you can make what's called a transformer. It just depends on how many loops of wire you have. So for example, if I have a lot of loops of wire and I put a current through those loops, I get a very large magnetic field. And if I then have another set of loops of wire that I put nearby, that magnetic field from the first loop goes through the second one, and as the field changes, you get a voltage coming off the second one. And it turns out that the ratio of the voltages you get is exactly just equal to the ratio of the number of turns of wire that you have. So down here, I have a transformer that I put together. Over here on the right-hand side, this thing has, looks like 220 or so turns on this coil. Over here, I have 110 turns. That means that on the output, I have twice as many turns as on the input. And when I put an AC voltage on the input, you can see that over here on this little meter, you see a number like about 30. That's the voltage going in. The voltage coming out, which is the number on the bottom, is twice as big as that. The reason is simply that we have twice as many turns on the output end of the transformer as on the input end of the transformer. So we can just use coils of wire, chunks of steel, and AC voltages to get high voltages. Okay? And so in fact, let me replace this one here that has only 220 turns with one that has 880 turns. Ooh. Okay.
That's stepping it up a lot.
You bet. So now I've got basically 8 times as many turns on the output side as on the input side. And so now when I run this experiment again, I should get 8 times the voltage on the output side as on the input side. And so let's see if it actually works that way. So now you see that you can get sort of 80 volts on the bottom with only 10 volts on the top. And this is AC volts now. So you can just imagine, if you wanted to make a very, very high voltage, you would just have to make a transformer that has a lot of windings on the output side compared to what's on the input side. And making a high voltage is a very important ingredient for transmitting electrical power, and that's what we're going to talk about in the next segment.
Okay. Look forward to seeing how that happens. Do you see how squirrels are involved in that in any way?
Oh, yes, we can talk about that. And in fact, we're going to put some birds on our high-tension wires, and I'm going to have the viewers tell me why the birds don't get electrocuted. So that's a very good question.
Okay. Well, we'll stay tuned for that. Thanks. Matt Sellen, the wise guy.
Why the birds make it and the squirrels don't.